Hi guys, today we're going to be doing the binomial theorem, and here's the notes that I gave you, so if you want to get those ready. First thing we're going to look at is something here called Pascal's triangle. So I want to redraw this. I'm going to move this for a minute, just so you can kind of see what this is. And maybe you've seen this before, but so Pascal's triangle is a triangle of numbers. So we start with a 1 on top, and we've got a 1 and a 1, and then we have a 1, 2, 1. And see if you start to see a pattern forming with this. 1, 3, 3, 1, 1, 4, 6, 4, 1. If you haven't seen this pattern yet, if you look on your notes, we always start with a 1 on the outside. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then we end with a 1. So just kind of a cool triangle. On your notes, you have to fill in this next row here. So there's the 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 15, 6, and 1. So great. Why do we need this? If you look here on the side, a binomial is just something plus something else. Here I've got a plus b. Anything to the 0 power is going to give us 1. A plus b is 1a plus 1b. If I were to FOIL or multiply a plus b squared, let me just show you what you get here. If I do a plus b, if I multiply this out, I get a times a is a squared plus 1ab plus another ab plus b squared. And if I rewrite it like this, I've got 1a squared plus 2ab plus 1b squared. Notice the coefficients are these numbers right here. So what this triangle does is it gives us a shortcut to multiplying binomials. So I'm going to show you how this works. We're going to expand. Expand just means to multiply it out. X plus y to the 4th power. Before we knew about this triangle, what you would have to do is you would have had to do this. X plus y, x plus y, x plus y, x plus y. And you'd have to FOIL all that out. It gets to be kind of a mess. So instead of doing that, what we can do is look for the row that has the second number being a 4. So I'm going to look at the 1, 4, 6, 4, 1. And I'm going to write out those numbers. I've got 1, 4, 6, 4, 1. And I'm purposely leaving spaces between those. The next thing I'm going to do is I'm going to take my first term, which is an x in this case, and I'm going to write x to the 4th, x cubed, x squared, x to the 1st, and then no x. If you wanted to see that, that's really technically what it looks like. Just remember, anything to the 0 power is 1, so I don't really need to even write that. Then I'm going to take my second term, which is a y. I'm going to start at the end, and I'm going to write y to the 4th, y cubed, y squared, y to the 1st, no y to the 0. I'm going to multiply everything together in each of these terms, and I'll be done. So 1 times x to the 4th times y to the 0 power is just x to the 4th, plus 4x cubed y, plus 6x squared y squared, plus 4xy cubed, plus y to the 4th. And that's our answer. We're all done. Yay! Way easier, way faster than trying to FOIL that out 4 times. So notice I put pluses between everything, between all my terms. That's because this is a plus. I'll show you later in a little bit what happens if that's a minus, but for now we're just going to work with a plus, positive sign. Okay, let's try one that's a little bit more complicated here. So if you notice, this is to the 5th power. So I'm going to look at my row that has a 5 in it. So I'm going to start by writing out those terms and make sure you give yourself enough room here. So I've got a 1, a 5, a 10, a 10, a 5, and a 1. Like how I'm color coding this? You guys could do that too. It's kind of fun. Okay, take the 2p. Now, when I did the x, it was real easy. I just did x4, x cubed, x2. What I need to do here is 2p to the 5th, but all of it to the 5th. So I'm going to put parentheses around it. And it's 2p, all of it to the 5th. Excuse me. And then 2p, all of it to the 4th. 2p, all of it cubed. 2p squared. 2p to the 1st. And then I'm not even going to write it there because it's to the 0 power. I don't need it. Then I'm going to take the q. I'm going to start at the very end, and I'm going to start with to the 5th power, and then just decrease it as I work my way back to the front. And I'm not going to put one there. One way to kind of check to make sure you're doing these right before you simplify, if you look at your exponents, 2 plus 3 is 5, 2 plus 3 is 5, 1 plus 4 is 5. They should all add up to 5. All right, so what I'm going to do is I'm going to simplify all this. Actually, before I go to my answer, let me just show you. This right here really means 2 to the 5th power, p to the 5th power. This right here really means 2 to the 4th, p to the 4th. 2 cubed, p cubed. 2 squared, p squared. Oh, that one's just 1. So 1, that's a 32. 1 times 32 gives me 32p to the 5th. We've got a plus here, so I'm going to put a plus between all of these. Sorry, that's my dog running around. Hear her little bells. All right, 2 to the 4th power is 16. So 5 times 16 gives me 80p to the 4th, q to the 1st, plus 10 times 8 is 80, p cubed, q squared, plus 10 times 4 is 40, p squared, q cubed, plus 5 times 2 is 10, p q to the 4th, and then finally plus q to the 5th. So that is expanding, multiplying using Pascal's triangle. Now, if you guys look at that next example here, it's to the 8th power. So unless you want to keep making that triangle, it kind of gets to be a bit of a pain at times. So we can also use something called the binomial theorem. Binomial meaning 2. And this is just another way to come up with, sorry, I'm having camera issues here. Another way to come up with these numbers, the 1, 5, 10, 10, 5, 1. So make sure you have a calculator handy. All right, so binomial theorem. I am going to just come up with a just simple binomial, a plus b, and to the nth power. What the binomial theorem says is that to come up with those coefficients, I'm going to do n, which is that exponent, c, and I'm going to start with a 0. You guys remember in class when I had you type a number c0 or number p0, it was always 1. That's where that 1 comes in. And then I'm going to have nc1, nc2, all the way until I get to ncn. So you would just keep going until these numbers end up being the same. All right, now, like before, that a, we would just do this, a to the nth power. This is going to be 1 smaller, so it'd be n minus 1. This would be 2 smaller, so it'd be n minus 2, so on and so on and so on. This right here would finally be a to the 0 power. The b, the second term, I would start way over here at the end, and that would be b to the nth power. Here it would be b to the 0. This would be b to the 1st, and this one would be b squared. I'd put my plus signs between everything, and that is the binomial theorem. It's essentially the exact same thing. I know this looks very ugly, but we're going to do the exact same thing we did here. The only difference is that instead of just coming up with these numbers, we're going to use the combination, the C, to help us figure those out. So let's try one. Write small because I have an 8th power here for you. Didn't. No. All right, so you know what? I'm going to get a piece of paper. And yeah, I'll try, never mind, I'll try this. We'll try this. If I go off the paper, just deal with me. All right, so I'm going to start with my 8C0. Leave a space, and I've got to do 8C1, 8C2, 8C3, 8C4, 8C5. Oh, this is going to get close. 8C7 and 8C8. I kind of made, I don't know if I can write anything in between those, but we'll try. We're going to take the x and do x to the 8th power, x to the 7, 6, 5. Hopefully you guys are catching on to what we're doing here. 2, 1, I'm not going to write one there. Now I need to take the y, and I'm going to start at the end. I'm going to do y to the 8th, 7, 6, 5. Look at these exponents. Do you see how they're adding up to 8 every time? It's a good way to kind of check. And then that one doesn't get one. All right, it's a plus. I'm going to put pluses between all these, but what I need is I need to come up with what these numbers actually are. Now we know it should always start and end with a 1, but do you guys remember how to type in the calculator with these? I would type 8. Remember, it's in PRB right here. It's the second option. If you have a different calculator, you have to figure out where it is. So that gives me a 1. A quick way to change it would just be go up, highlight it, recopy it, and change it to a 1. Go back up, highlight it, change it to a 2. So far I've got 1, 8, 28. So this is a 1, this is an 8, this is a 28. We can go back up, change it to a 3. I'm at 56. I don't know if you guys noticed, but before these numbers actually should start to repeat. 70, haven't repeated yet. That's a 5. There's my 56. So sorry if I went too fast with that. Once it starts to repeat, you can check them all in the calculator, but then this should be a 28. This should be an 8, and then finally 8C8 be 1. Remember, there's only one way that you could have a group of 8 people and get all 8 people. All right, so if I'm going to write my answer out here, I have 1, I'm not going to write the 1, x to the 8th plus 8x7y plus 28x6y squared plus 56x to the 5th y cubed plus 70x to the 4th y to the 4th plus 56x cubed y to the 5th plus 28x squared y6 plus 8xy7 plus y to the 8th. I barely made that fit. All right, so that's the binomial theorem. On the back side of your notes, this time I'm going to show you an example of a subtraction problem.